All right, hi everyone. This is chapter 1, lesson 1 for Ravenclaw on rational numbers. So rational numbers is the title of this lesson. And as you can see here, we have a lovely picture diagram of what rational numbers are. So basically we've learned a lot about what numbers are and different types of numbers. So natural numbers are numbers 1 through infinity. They have to be whole numbers. They're inside the whole numbers, which includes 0, so 0, 1, 2, 3, 4, so on and so forth. Then you have integers, so that includes all the negative numbers and all the positive numbers. Okay, then you have rational numbers, and rational numbers are what we're going to be talking about during this lesson. So as you can see down here at the bottom, let me zoom in for you, make it a little bit easier for you guys to see. Okay. So there's the bottom. Move things around a little bit so you guys can make sure everything's seen. Right? There we go. So at the bottom I have numbers that can be written as a comparison of two integers expressed as a fraction are called blank blank. In those two blanks, you're going to write rational numbers. So those two blanks, you're going to write rational numbers. So a rational number is any number that is a comparison of two integers. So basically, if you can write it as a fraction, it's considered a rational number. Now the next one says the decimal form of a rational number is called a blank blank. You're going to write repeating decimal. Okay. So a repeating decimal is something that goes on forever. It repeats. So like 0.99999 and it goes on forever. That's a repeating decimal. You can also have repeating decimals like 02020202. Or 123, something along those lines. It's a repeating pattern. If the repeating digit is 0, then the decimal is a blank blank. And in those two blanks, you're going to write terminating and decimal. So terminating decimal. So that's if it stops, if it truncates, also called stopping, it's a terminating decimal. Okay, so now we can move on to our next page. That's page 9. Let me zoom out for you so you can see the whole thing. Okay, so at the top it gives us some examples, right? So the first example it gives me, those are really hard to see, so they're really tiny. I want to make sure you can see them. Okay, you should be able to see them now. All right, so the first example they give me is write each fraction or mixed number as a decimal. So I have 5/8, 5 divided by 8, so that's what that means. So basically I'm just gonna walk through the division and that's how I'm gonna figure it out, okay? I get 0.625. Now if I were to continue on this path, I would get zeros, which means it's a terminating decimal, it stops. So it is a rational number, okay? Example number 2 is -2, 1 2/3. So -1 2/3 can be written as -5/3 because I can change my mixed number to an improper fraction, which is what I did here. And then I divide 5 by 3 and add a negative sign. So when I divide, I get 1.6 repeating. Okay? So 1.6 repeating, that's what the little bar over the top means. So the mixed number is -1 2/3, but it's a 1.6 repeating decimal. Okay. For number 3, number 3, in a recent season, St. Louis Cardinals first baseman Albert Pujols had 175 hits in 530 at-bats. To the nearest thousandth, find his batting average. So thousandths, make sure when you're solving this that you only round to the thousandths place, okay? To find his batting average, I divide the number of hits 175, by the number of at-bats, 530. So 175 divided by 530, and you can actually put that in the calculator. So here's my calculator. Clear that, okay? I'm gonna do 175 divided by 530. Push enter, and I get 0.330188679. It goes on for a while. I want to round to the nearest thousandths place. So here's my tenths place, the first three. Hundredths, thousandths is at 0. So 0.330 is his batting average, which is what we ended up with. Okay. Then I have problem number 4. Okay. Problem number 4 says write 0.45 as a fraction. So what I'm going to do is I'm going to take 0.45 and it's 45 hundredths, because that's the hundredths place. So I can rewrite it as a fraction to 45 over 100. Then all I have to do is simplify. Well, 5 goes into both 45 and 100. When I do that, 45 divided by 5 gives me 9, and 100 divided by 5 gives me 20. So I get 9/20ths. And that's as simplified as it can get, so that's the answer for number 4. Okay. Number 5, the last one here that it's done for us, okay, is write 0.5 repeating as a fraction in simplest form. So I have to assign a variable to the value 0.5. So let's say it's n, okay? Then I perform the operations on n to determine its fractional value. So n equals 0.555, and the decimals keep going, right? If I multiply both sides by 10, I get 10n equals 5.555 repeating. Keeps going on and on, right? Then I subtract then I subtract n equals 0.55 to eliminate the repeating part. So basically I subtract 1n, right? So I'm left with 9n equals 5. So I took 10n and I subtracted 1n from it. Remember, there's an imaginary 1 here. So 10 minus 1 gives me the 9. 5.555 minus 0.55 repeating gives me 5, right? Because we said 1n was this. Okay, so we subtracted 1, basically 1n from each side, and we got 9n equals 5. So then I have n equals 5 over n, okay? So this, the decimal, 0.5 repeating, can be written as 5/9, okay? So now you have a couple of try it problems. As you can see on your page, here's the try it. Okay, you've got 1, 2, 3, 4, 5, 6, 7 try it problems. So go ahead, pause the video now, try them out on your own, and then we'll go over the answers together. All right, now that you've tried the answers on your own, let's go over them together. So the first one that I'm going to look at is A, B, and C. So the first 3 there, okay? The directions for those are write each fraction or mixed number as a decimal, okay? So I have 3/4 as my first one. 3/4, what I'm gonna take and do is I'm gonna take 3 divided by 4. And you can do this on the calculator, but 3/4 is one that you probably should know. So I'm gonna take 3 divided by 4. It gives me 0.75. So 3 divided by 4 is 0.75, okay? I'm gonna do the same thing with -3 and 1/11. So first I'm going to change -3 1/11, which is a mixed fraction, into an improper fraction. You can do that by multiplying. 11 times 3 gives you 33, plus 1 is 34. So this becomes -34 over 11. Okay. So I'm going to do 34 divided by 11. That gives me 3.090909091. Now, if the calculator kept going on forever and ever, notice we have this pattern of 090909. What this 1 means is that that pattern actually continues, but they rounded the 0, because that 9 would be the next number, so they actually rounded the 0 to a 1. So when I write this, first it's going to be negative, because that's what my sign says. I'm going to write 3.09 with the bar over 0 and 9. If you only put it over 9, it just tells you the 9 repeats, but you repeat the 0-9 pattern, okay? The last one I'm going to do is -2/9. So I'm going to plug it in. I have 2 divided by 9, and I get 0.2222222, that just tells me that it's a repeating decimal. So I'm going to write it, and because it's negative, I have -0.2 repeating, okay? Then I have D, 4 and 13/25, which I'm also going to change into a fraction. I'm sorry, into a decimal. So one thing I can notice is 25. I can easily multiply that by 4 to get to 100. So if I do that, if I multiply this by 4 and the 13 by 4, 13 times 4 gives me 52, and 25 times 4 gets me 100. Well, this I can easily change into a decimal. 4 is my whole number, so that goes in front of my decimal. And then 52 over 100 just becomes the 52 behind. Okay? All right, the next one I have is E. In a recent season, NASCAR driver Jimmy Johnson won 6 of the 36 total races held. To the nearest thousandth, find the part of races he won. Okay, so that's very similar to problem number 3 that we did. So I'm going to take, first I want to know that I'm going to the nearest thousand, so that's important. I'm going to take the amount of races he won, and I'm going to divide it by 36. So I'm going to take my calculator, 6 divided by 36. That gives me 0.16666, and it repeats on forever. Notice the 7 here at the bottom means I probably rounded up at some point. The calculator rounded up for me. So I want to round to the nearest thousandths. So this is 0.16 with the 6 repeating, right? But if I had this as thousandths, 0.166, so that's tens, hundreds, thousands. There is another 6's back here because they keep on going forever, right? So this 6 tells me I have to round this up, so I get 0.167, and that's the part of races that he actually won. Okay. Then I have F and G. F and G asked me to write each decimal as a fraction or a mixed number. So the first one I have is -0.14. So I'm going to put 14 because that's the number behind the decimal. And that's read as 14 hundredths because there's 2 places, so 2 zeros. Okay, and it is negative, so I'm going to put the negative sign out front. I can divide both 14 and 100 by 2. 14 divided by 2 gives me 7, and 100 divided by 2 gives me 50. So my fraction is -77 over 50. Okay? Then I have G, right? And G is very similar to problem number 5. So I'm going to go ahead and set it up. I'm going to say n equals 0.2727, and it repeats because the bar is over 2 and the 7, right? Okay. So that's what n equals. I'm going to multiply both sides by 10, and all that does is just move the decimal. Okay. So I multiply this by 10. So I get 10n equals 2.727 repeating. Actually, I want to multiply this by 100 because that'll get me 27.27, which is what I actually really want, right? So I'm going to multiply this by 1n, so I get 27. So this gives me 99n equals 27. I divide both sides by 99. So n equals 27 over 99. Sorry about that. Okay. So I'm multiplying by 100n. When I multiply both of these sides by 100, this becomes 100n equals 27.27 repeating. I subtract 1 from both sides. That gets rid of my decimals. So I'm left with 99n equals 27. I divide both sides by 99. So I get n equals 27 over 99. However, both of these are divisible by 3. 27 divided by 3 is 9. And 99 divided by 3 is 33. These are also both divisible by 3. So I end up with 3 11ths. And that's my final answer, 3 11ths. Okay. And that is the end of chapter 1, lesson 1.